This is the confusing part right here, right? So each iron gives 1, so this whole thing is going to be iron 1 oxide. Right? That's a little bit weird, right? Each iron here, if you draw it out, it makes more sense. Think about this. You've got one iron atom right here, you've got another iron atom right here, and you've got an oxygen atom right there. That oxygen atom is going to be taking 2. So it's got basically 2 holes in it. You can think of it that way if you like. 2 holes, and they need to be filled by iron. Well, how much is each iron going to give so that that oxygen is going to be satisfied? 1. This one's going to give 1, and that one's going to give 1.
But when they
So the overall name, though, is not iron 2 oxide because that doesn't capture what's going on in this scenario. Iron 2 oxide would mean that both of these irons give 2 electrons. And here we want to know about how many each of these iron atoms give. So in this case, it's iron 1 oxide. Okay? Think about each iron giving. How many does each give?
So in reality, the
Wait, his hand was up before you started talking.
Sorry.
Yes.
So if it's calcium bromide 2, and if it's a non-metal plus a metal, you don't have to like write the numbers.
That's right.
Okay.
No number is needed for that because it's just a regular metal, and then it's a non-metal over there. Good question. Yeah.
you don't really need to know what the transition metal is other than to write the name, right? Like, it doesn't make a difference if it's gold, iron.
It doesn't matter. No, I could give you anyone. I could give you tungsten right here, and it'll be the same thing, the same scenario. It's just a name to fill in.
Yeah.
You need to know how many that transition metal is going to give,
But
and
it's
you have to
the
figure it
version.
out backwards in a kind of roundabout way.
Yeah.
So you're going from this is the formula, and you're going to the name.
Yeah.
Formula to the name. We can go backwards now. How about we do that? Let's do that. I'm going to use the same scenario now, except for iron oxide. I'm going to say, okay, instead of iron 1 oxide, I'm going to say this is iron now, iron 6 oxide. What? This is crazy. How am I going to figure this out? Well, first thing I'm going to do is I'm going to just write down the symbols, because I know those are going to be used. And now I have to think about this, okay? I'm going to look at this and think, okay, well, how many is iron giving here?
6.
6. Iron's giving 6. All right, so iron's giving 6. Give 6. How many is oxygen taking here?
2 each time.
Oxygen's taking 2. Takes 2. All right.
So you
Now-
switch it.
Now you can figure out just through the crisscross applesauce. So here, that's going to be 2. And over here, and I know what you're going to say. You're going to say, Mr. Sid, do we need to reduce it? And I say, you could. You don't have to. It's still right. It's the right ratio. So this you could simplify if you like, if it makes you happy.
Can simplify in chemistry?
Everything's simple in chemistry. So it's kind of hard to simplify it anymore. But we can try.
You don't have to.
Let's do this. Fe, and then what would this be?
3.
Yeah, that's it. Okay?
But that would also make more sense because if you look at it and there's 6 and oxide takes 2 each time, then there would have to be 3 oxygens.
Yeah. Good. Right? This is just this way right here just lets you get the right ratio.
Yeah. But you don't have to simplify, do you?
I think I'm gonna see. You should just read
You
or
said you
watch
don't
this
have
again.
to.
Watch it again. Watch it again. Watch it again. I know I said at least twice. Maybe I didn't say twice. Maybe I just said it once. Well, now I just said it twice.
We're doing polarity now.
Yeah. All right. Any more questions about this? This is the most the point sapping part of our test. I guarantee it. You guys are gonna have difficulty with this just because there are some steps you need to take to make sure that you are absolutely correct with these. One thing I would do just to make sure with these is to actually write out these atoms here and make sure, like for this one right here, iron 6 oxide, make sure it makes sense to you. Iron, and then this iron is giving away 6 to oxygen. Well, then how many oxygen must there be? Okay, there's got to be at least 3. All right.
So would we get points off if we just wrote this instead of simplifying?
No.
A question.
All right, Paulette, yeah.
No, not about this kind. Just while you're reading.
Okay.
What's the Friday schedule right now?
Now we're going to be on, when we get out? the very end?
Like I don't.
You want to know the end of the day?
No, like what time does all these like what's the time?
Oh, we get done at 9:15, and the next class starts at 10:45, and it gets done at 11:20.
So the classes are shortened.
Classes are short. I think it's just 5 minutes. Oh, we only have 5 minutes left. Oh man, we can do this. We can do Lewis dots and polarity in the same breath.
I'm an alien.
Let's say that I give you the formula this. You're an alien? Cool. All right. We've got this formula right here. So simple. Oh my god. And then we want to write the Lewis dot structure. And then from the same formula, we want to write the polarity. Is it polar or is it not polar? Polar. Polar? Question mark? You say yes or no. So what do you think? Let's do the Lewis dot structure first. Yeah, how would you do it? Tell me about the method.
You just put carbon in the middle.
Well, the method is you put carbon right there.
Yeah.
Okay.
Oh, the method. Okay,
The method.
so C, and then put 4 dots around this carbon, and then put 4 hydrogens with 1 dot around it. And then you just connect the dots.
Connect the dots. Here's his tip. Whenever you have a single dot, make it bold. Make it bold and strong, because the single dots are the things you need to connect. Okay?
Yeah.
That helps. It seriously helps. So now you have to look at all the single dots, and they're going to go right here, right there, and right there.
Put your hands up.
Put your hands up.
Up in the club.
There we go.
Try to
Let's
touch
rewrite this. Let's rewrite it like this. Just like a grid. And yes, you will be marked off if you don't write it back in this little grid form. So you have to write it in a grid.
We draw the shape.
You're prejudiced against non-grids.
I'm against grids, or non-grids, yes. This little swirly thing, not happening.
At the beginning of the chapter, you told us to always do, like, there's numbering around the atoms.
Yes.
Does it still matter?
In this case, yes. In this case, yes. Because let's imagine that you did this. I can see people doing this tomorrow. I can see them doing this. Oh, there's 4 dots around carbon. Okay. Well, let's connect the H's right there, and then you can draw it like this. Oh my God, they'll think that this is right. I drew it in a grid, Mr. Sand. Isn't that right? No, it's not right. We've got these dots right here, and then each one of these bonds now represents 2 electrons. So look how many electrons are around carbon. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's not right. So make sure you count these dots right. Now, another thing that's going to come up tomorrow, I'm sure, is when you have a structure like this. I'll do this really quickly. This, where you have, like, I don't know, like this. And this is kind of like a pretty easy question I'd ask. On the test tomorrow, I'm going to ask an easy question, a medium difficulty question, and a difficult question. Okay? So this one's probably one of the easier ones right here. You have to write out all the atoms, like we did over there.
Do that.
Let's do all the dots. And then we've got the H's. Alright. And now we've got the O. Now how do we draw the O?
It's 6, so you draw an O, 1 dot on top, and then you keep going like that.
Just keep going like this?
Yep.
Until we hit what?
Stop with that one.
This one's right there. Yes. If you don't do that clockwise sort of distribution of dots, you're not going to see that there are 2 single dots on these sides that are now bonding. Okay. And then we also have this extra H right there. A common mistake is people put this dot over here. So now you don't know where the bonding electrons are. So you need to put that electron right over here. So if you do this, now you can see it's pretty clear. You can see where the single dots are and where the double dots are. The double dots are the non-bonding electrons. Yeah.
Do we have to draw that out tomorrow? Or can we just if you know how to do it already, do you know?
Right, but if you skip a step, you might not catch everything.
I'm saying let's say
You know what I
you're
mean?
low on time or something. Do you have to draw all the things, or is it okay if you just draw the equation?
The final product, you can do the final one. I'm not going to take up points, but I'm telling you, you're going to shoot yourself in the foot because you're probably going to make some silly mistake if if you don't do this full procedure like this. Because you guys you don't have years of practice with this. It takes years to be fully comfortable
Like
with this.
one like that one, I know that. Like CH4.
Like CH4, yeah, you could do that right
I'm
away.
saying like a harder ones, obviously, I do that. But I'm saying like
Right.
the easy ones, like I can do them in my head.
Okay, yeah, you could do that. Mason, what's up?
We have to write the Vesper.
Yes, you're going to need to write the VSEPR. And the VSEPR is a chart that you're going to get. So don't worry about memorizing that chart. You don't need to memorize
You
that.
put every single shape too, right? Like this one example is 2 shapes. So it's gonna be the tetrahedral.
Yeah, well, I'll make it clear.
Okay.
Like on the test tomorrow, I'd say, oh, well, what is the shape around the bold atom?
Oh, okay.
And and then you do it around that oxygen. So in this case right here, let's just finish this problem real quick.
And then with oxygen.
And then we have oxygen, and then I'm going to put 2 dots like this, and then I'm going to put
one hydrogen.
right there. Yes,
And then
that's the final Lewis dot structure. Now
And
you can
it's
write that several different ways, but make sure that you have the double dots
Or linear.
right there, the lone pairs right there. Now, is this one polar?
No.
Which one?
This. No! And it's going to have, I'll have a different column over here for the VSEPR. But its VSEPR shape is going to be tetrahedral. And what IMF is it going to have? Oh, let's just go there.
Ooh.
Non-polar.
Diplo.
What's it called?
No, Van
Yeah, Van der Waals.
Van der Waals.
Van der Waal.
Van der Waal, there we go.
Vander.
My Van der Waal.
Yeah,
Over here,
when you
this
sing
is
that,
polar.
You seem like a,
Yeah.
you seem like a Bjorn baby.
Oh.
You know
Oh.
Bjorn babies?
I don't know what you're talking
Bent.
about.
Swedish babies.
Oh.
Bent.
That's going to be bent. Yeah, good. Bent at 109.5. You got it. Okay, study tonight. And,
You kept on saying the test was tomorrow when the visitors were here.
oh, I forgot. It's on Monday. Monday. See you later.
Yeah.
This will be online.